Hello, ladies and gentlemen. It's been several days since we've seen face to face, and I want to thank those of you who showed up on our Zoom meeting on Wednesday of last week. We had a couple students per class show up. I would have loved to have seen more, just kind of touch base. We didn't talk about anything in particular. We're just trying to see how everything was going on at home with your families and yourself, and trying not to get too overwhelmed with homework. So then today, obviously, we took the day off. I had some things I had to do from a counseling perspective. So we're back at it. On Monday, we kind of introduced you guys to arthropods. And the arthropods, when you look at the name itself, arthro meaning jointed, pod meaning foot. And these are two of our root words that we had the other day. So insects are jointed animals with many feet. That's essentially what the term means. Jointed animals with many feet. And when you think about an arthropod, I want you to think insects, spiders, crustaceans like lobsters and crabs. Probably the most prominent characteristic are all of the legs and the length of those legs. All of those creatures are going to be arthropods. So some general characteristics of arthropods, and this group is interesting because it's right in the middle of evolution. You're going to see some things with arthropods that are just a step above what we've seen so far. Okay, so the first one here is being the development of the skeleton. This is the first creature, the first group of organisms that have some sort of protective structure on their body. Obviously, for humans, we have an endoskeleton, which is a skeleton on the inside part of our body. The exoskeletons are going to be on the outside. Exo meaning outside. Again, one of your root words. Skeletons on the outside for support and protection. An exoskeleton does the exact same thing as the endoskeleton. The locations are different. That's the only difference. Okay. Arthropods, jointed appendages. Many joints, a couple joints, it doesn't matter, but you've got jointed appendages. And guess what? We have jointed appendages as well. For the most part, you're going to have certain body regions of an arthropod. You're going to have a head area, a thorax area, which is the chest. Okay, your thoracic cavity of your body is your chest cavity, and an abdomen. Okay, obviously for humans, we go down with the legs and toes and feet and things like that. But you've got head, thorax, and abdomen. And many arthropods have a head or thorax and an abdomen. Some arthropods only have what's called a cephalothorax. Again, go back to your root words. Cephalo means head. Thorax means chest. It's literally a body plan that's a head attached to a chest with some legs, and that's what the arthropod looks like. Okay, so a head and chest region fused together. Okay, cephalothorax. And then a unique characteristic of all arthropods is as they grow and develop, they will molt. They will shed their exoskeleton, and they'll have a new one ready to go right beneath it. But they'll go through a certain period of lifespan. It varies on the animal, varies on the environment, things like that. And then they will molt, much like a reptile will molt their skin on a monthly basis. Arthropods are going to molt their skin as well. So a couple of examples there. We've got, looks like we've got a cicada, which is very common to Illinois. And I'm not quite sure, some sort of crab right there, maybe a horseshoe crab or some sort of crab right there. Other general characteristics, this is the unique part about arthropods is we're not quite using lungs yet. Okay, we're in the middle of using gills, tracheal tubes, which will turn into the esophagus for the humans, and book lungs for gas exchange. So we've got a little bit of variety here with lungs, with gas exchange structures. It isn't until the next set of animals that we really kind of take off and just use lungs only. Simple compound eyes. We've got brains. We've got ganglia. And bottom line is we're well past the point where we're getting centralization, where we've got many, many different types of nervous systems and respiratory systems and circulatory systems. Now we're taking those systems and getting more complex with each system. Okay, so we've developed the systems over time, and now we start getting more and more complex with those systems, and the advancement of eyes being one of those examples. Using pheromones to communicate. One of the first animals that use chemicals or scent molecules that float through the air that only spiders can smell. Maybe other animals can smell them as well, but pheromones of every species are unique to that species and really only create a response mechanism in that species. They have open circulatory systems, and we saw that with the clams of the mollusks. Complete digestive system. There is a mouth, there is an anus, and then we have efficient means of waste excretions. So whether that's more advanced nephridia, whether we're starting to see the beginnings of kidneys, but we do have different means of getting rid of waste products. Okay, so all of these characteristics, again, we tie it back to the evolution of the animals that we've been talking about, all the invertebrates. All right, now some of you guys might not know this, but class Arachnida, the spiders. Okay, these are the most vile creatures on the planet. Okay, spiders are just creepy, crawly, they're nasty. I'm not a fan of spiders. Okay, why? Look at this picture. Okay, that is a spider. It's what they call is a wraparound spider. It's flattened its body. It's camouflaged to that tree. Imagine climbing that tree as a 12-year-old kid or 14-year-old kid or whatever, and that pops out of the tree. Thanks, but no thanks. I mean, we've got spiders that will attack hawks, and they are a prey species. They kind of prey on each other. You got the hawks that come down from the ground. These spiders are so big that they'll fight them off and then try to eat the hawk. Thanks, but no thanks. Spiders in Australia, thanks, but no thanks. Just nasty, nasty structures. So the arachnids, spiders, scorpions, and mites. Spiders being the largest group of arachnids in this little subgroup here. Most of the arachnids are going to have two body regions. You have a cephalothorax, you have a head and thorax region with an abdomen. Okay, so if you look at the structure here, this looks like this might be the head region there. Okay, and that would be the abdomen there. Okay, on the next picture, abdomen, much larger on the back end, and then you've got the cephalothorax region right here. There are structures called chelicera that are basically like modified jaws for poisoning prey, like modified teeth, modified jaws. When you think of a spider biting you, it's the actual chelicera that make the penetration into your skin. Think of them as fangs. You know what a snake's fangs look like. That would be a good analogy for what the chelicera are. And two what are called pedipalps, pedi being foot, for sensing and handling food. So when you look up here, you've got three sets of legs here. You've got what we call the chelicera are going to be tucked up inside here. And then the pedipalps are going to be these two little structures right there. So these guys handle the food. They sense the food. And then these chelicera come out and they bite and poison the food that these spiders have. And spiders are just nasty. All right. A unique characteristic of spiders are the silk glands. We know that spiders are excellent at spinning very ornate webs. They use them for homes. They use them to wrap up their eggs in a cocoon. They're used for protection. And it's known from an engineering standpoint that one silk gland has enough strength, maybe even more than enough strength as a piece of iron. Okay, that's how strong pound for pound these silk glands are. And spider webs, if an insect gets caught in a spider web, they're not getting out of it. Okay, they're simply going to be prey for whatever spider has spun that web. Ticks and mites a little bit different, and you guys have all seen ticks before. This would be an example of a tick right here. They have one body segment, so they've got a head, abdomen, thorax, all kind of into one structure. Ticks we know are parasitic. And we'll see a picture of an engorged tick. So this would be an engorged tick right here. There's a little tiny head of it. All the rest of this, that's mammalian blood. That tick has been feeding off of some creature, a dog, a cat, a human, deer, moose in the wild, whatever. And these guys can get pretty big, and they'll suck enough blood, and they get engorged on it, and they'll feed off of that over a long period of time. Mites, on the other hand, are microscopic. You're not going to be able to see a mite. You can feel them. A lot of times if you walk in grass with no shoes or socks on, you'll get little tiny red bumps that are very itchy. Those bumps are called chiggers, and those are the bites of very microscopic mites that you cannot see. Okay. The last one are the scorpions, many body segments, but the primary calling card of a scorpion here are the pincers up front, and then obviously the poisonous tail on the back. And there are certain scorpions that are poisonous with their tail and some that are not. I think the wives' tale is the larger the back end of the tail, the less poisonous the scorpion is. Don't hold me to that. It's the larger this back end, the more it's more for show to try to scare off the prey or whatever. And the smaller ones are the ones you have to worry about. Those are the ones that are filled with poison with a venomous stinger at the end. The second class that we'll talk about is class Crustacea. If you've ever been to Red Lobster, you're eating a crustacean. They're all aquatic. So in other words, they have to use gills for gas exchange. So obviously, we're not going to use lungs or tracheal tubes for this. Unique calling card. They all have 2 pairs of antennae. They're using these to sense, vibrations in the water and food and movement and things like that. Using mandibles, which would be modified chelicera or modified jaws to crush their food. They do have eyes. Again, we talk about centralization and the nervous system getting more and more complex. These guys have eyes on movable stalks. 5 pairs of walking legs for seizing prey and cleaning their appendages. And the first pair is often modified into strong claws. Okay, so you guys have all seen what a lobster looks like. You've got these little swimmerette type of appendages down here. You've got 1, 2, 3, 4, 5 pairs of appendages, and the first one being some sort of modified claw. Okay, and then crabs will have the same one, same type of structure. Okay, you see the antenna, 2 pair, a longer pair, and then a smaller one. I'm sure they both have different uses for the different lengths. But again, these are just different modified types of arthropods. 3 body, most have, some have 2 body segments, some have 3. So we know we've got some crustaceans are going to have that abdomen and the cephalothorax region, whereas some of the crustaceans will have a complete head, a complete thorax, and a complete abdomen. And then we do have some crustaceans. If you ever flip over a piece of rotting wood in your garden or whatnot, and you see the little tiny pill bugs scattered everywhere, those are types of crustaceans. They use lungs. So they have to live in moist environments for gas exchange. All right, but those are types of crustaceans. Different pill bugs right there. The little sometimes you call them roly-polies. That's what we used to call them growing up. Then you get to the insects. So these are the ones you probably have most familiarity with. Largest group and most successful group of arthropods. Every night you can sit outside in the weather and get some sort of fly, some sort of mosquito, some sort of cicada. All of these are going to belong to class Insecta. Okay. The unique thing about insects, and I didn't really realize this until I first started teaching, is that an insect only mates once or twice in their lifetimes. Which, if you got a group of mosquitoes, they're not very efficient at reproducing, which is interesting because they have internal fertilization. Insects, from a sexual standpoint, are kind of similar to humans. Okay, humans are going to have only a certain number of offspring, whether it's 2, 3, 4. You're not talking about thousands of offspring, and they have to have internal fertilization. So, in other words, a mosquito has to find a mate for reproduction, and they have to. There's got to be male sperm inserted inside the female to find the eggs. Now, they could have several thousands of eggs, but, they mate once or twice internally. Lots of sperm will reproduce and find lots of eggs. That's a difference in humans, obviously. Females will lay the eggs. They're not going to protect their eggs. Once the eggs are laid, they leave them, and they're there to fend for themselves. Mosquito eggs, once the female lays eggs in the ground or in some sort of watery environment, those mosquito eggs will turn into larvae, and those larvae will then obviously turn into mosquitoes. So as far as a life cycle for insects, there's what we call complete metamorphosis or incomplete metamorphosis, okay? And it all comes down to when the eggs are laid, what happens after the eggs are laid? If the eggs turn into larvae, okay, then turn into a pupa, and then turn into the adult, you have complete metamorphosis. So a butterfly would be a great example. Eggs turn into caterpillars. Caterpillars will go into a cocoon and change over time, and then the butterfly pops out. This would be a monarch butterfly. Okay, that's complete metamorphosis. Complete metamorphosis is probably what we do, to be honest with you. Okay, egg develops into a baby grasshopper, what we call a nymph. Okay, and then the nymph simply gets older until it reaches adult size, and that's what you've got. Okay, and then this guy's got to find a mate for reproduction to lay more eggs, and the process starts over. All right. So obviously, humans, we have egg and sperm to form zygote. Zygote develops over time. You're born, you're a child, and you simply grow to your adult size. All right. And then nymphs, again, they're babies. They're just like humans. They've got to have resources, and they're compete with adults for the same resources. They just can't find a mate yet. All right. So those are the insects. Those are the arthropods. I've given you some brief readings and an outline to do for homework.